Good morning to all of you. Good morning, all of you. Today, I will discuss about insertion sort. You know, insertion sort is the one of the technique of your sorting algorithms. You know, sorting sorting is the arranging of your elements in your sequentially fashion. That is your sorting. Okay, there are many types of sorting like your insertion sort, merge sort, radix sort, quick sort, bubble sort, selection sort, insertion sort. There are so many techniques. Insertion sort, one is the most important technique of your sorting. So today I will discuss about the sorting. You know, insertion sort, this is in place of a comparison based sorting algorithm. Okay, now I am presenting my screen. Wait, I think you can see my screen. Yes, today I will discuss about the insertion sort, and in this lecture I will cover so many topics like your what is insertion sort in your data structure, and example of your insertion sort, algorithm of your insertion sort, implementation of your insertion sort, and advantage and disadvantage of your insertion sort. Okay, I will cover many topics one by one. First is that what is insertion sort? You know, as per I had told in starting, this is an in place comparison based algorithm. Okay, and in insertion sort, sublist is maintained, which is always sorted. This is your key point of your insertion sort algorithm, and array is searched sequentially in this insertion sort, and unsorted items are moved and inserted into the sorted sublist. This is your insertion sort. In your insertion sort, array is searched sequentially, and unsorted items are moved and inserted into the sorted sublist in the same array. This algorithm is not suitable for large data set. This is the limitation of your insertion sort, that this algorithm is not suitable for the large data set, as its average and your worst case complexity. Okay, and now I am taking the example of your insertion sort When you want to take the array, array is the array you will take for your insertion sort. You know, array is the collection of your similar type of elements. Like suppose you are taking the numbers of your student, so you know all numbers are in your integer form. So for storing the numbers of your all students, you will take the array. That's why I had told your array is the collection of your similar type elements. So for the insertion sort, first of all, you will take the array, and in this array, you will store so many items. Here, when I am taking the array, so I will store some items on your array, and these items are not in your not in your sorting form in your array. And my purpose is that through the insertion sort, I will sort the all items which are present in your array. Suppose I am taking some elements which are already inserted in your array: 14, 33, 27, 10, 35, 19, 42, and your 44. Yes, Arprit Preet and Pratik. Arprit Preet and Pratik.
Yes, sir.
Yes, sir.
Arprit. Arprit.
Yes, sir.
Yes, Arprit Preet. Arprit, I am talking to you. Okay. Yes, Pratik. 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 Yes, Mariam.
Yes, sir.
Yes, sir.
Yes, Mariam.
Yes, sir.
Mariam, are you present
Yes,
in class or not?
yes, sir. Present, sir.
Mariam, speak something. Yes, Mariam, speak something.
Yes, sir. Hello. Yes, sir.
Okay.
I'm in
Okay,
class.
okay, okay. Your mic is not working. Okay, no problem. In this shared screen, you can take, I have taken one array, and your array is that 14, 33, 27, 10, 35, 19, 42, and 44. This array is not in your sorted form because 14 is greater than from your 33, 33 is greater than from 27, 27 is greater than from your 10, 10 is greater than from your 35, and 35 is greater than from 19, and 19 is less than from your 42, and 42 is less than from your 44. So you can see in this given PPT, your items are not in your sorted form. So your object is that through the insertion sort, you will sort these items which are present in your array. Okay. So your array is your 14, 33, 27, 10, 35, 19, 42, and your 44. Okay. So first of all, you will insert the all elements in your array, and after that you will compare first two elements. Your two elements are 14 and 33. When you will compare these two elements, that is your 14 and your 33, so 14 is less than from your 33. So if your 14 is less than from your 33, that time your swapping is not required, because as per the your sorting fashion, when you want to sort it in your ascending order, as per your ascending order, your first element should less than from your second element. So here, when you have to compare first two items, that is your 14 and your 33, so 14 is less than from your 33 means here is swapping is not required, because 14 is less than from your 33, and your 14 and the 33 are already in your sorting fashion. Okay, and now your insertion will move ahead, and you will compare the 33 with your 27. At this time 14 have already taken a place in your starting position, and now 33 will compare from your 27. So when you will compare the 33 from your 27, so 33 is greater than from your 27, and as per the rule of your sorting, your first element should less than from your second element. But when you have to compare between 33 and your 27, so 33 is greater than from your 27 means here is swapping is required. Yes, Pratik Mukherjee. Yes, Pratik Mukherjee. Pratik Mukherjee.
Yes, sir. Yes, sir.
Pratik,
Yes, sir. I'm right
I am
here, sir.
asking from you about the swapping. Pratik Mukherjee, I am asking from you about the swapping. What is swapping? Yeah, I know you are here, but I am asking and you can speak, no problem. But I am asking from you what is swapping and what is the concept of your swapping.
Sir, swapping refers.
Pratik Mukherjee, I am asking from you. You can speak, no problem. Okay, I think your mic is not working. Okay, no problem. So as per I have told, your 33 is greater than from your 27, and as per the sorting, your first element should less than from your second element. So here a swapping is required. I think all are known about your swapping. Swapping means you will interchange the value between two variables. Like suppose you are having two variable. First variable is your a and second variable is your b, and your the value of a variable is that 10 and the value of b variable is that 20, and you want to swap them. So after swapped, your variable's value should be A will hold the 20 and your B will hold the 10. So that is your swapping. And what concept you will follow for the swapping? I had told many times in my previous classes, you can swap with your third variable, that is your temp, and also you can swap without your third variable. I am telling about the swapping with the help of your third variable. Suppose you have taken the third variable, so your concept should be temp assignment operator A assignment operator B, and your B assignment operator your temp. So as per I had told in your first statement, temp assignment operator A means in this first statement, the value of A will assign into your temp variable. Temp is your temporary variable. You can take any other variable without your temp, no problem. But here I have taken the temp variable. Okay, so your A variable's value will assign into your temp. Okay, and in your second statement, the value of V will assign into your A variable, and in your third statement, the value of temp variable will assign into your V. After execution of these three statement, your value will swap. That time your A variable will hold the value is 20 and your V variable will hold the value is 10. That is your swapping concept. Okay. So as per I had told, when you will compare your 33 from your 27, 33 is less than, sorry, 33 is greater than from your 27. So that time you will swap both, means your 27 will take the place of your 33 and your 33 will take the place of your 27. If swap 33 with your 27, you will also check with all the elements of sorted sublist, and the sorted sublist has only one element 14 and 70 in greater than from your 27. So sorted sublist after swapping will be as per I had told, your 14 is less than from your 27. That time your swapping is no required, because 14 is less than from your 27. And you will compare again 33 from your 10. When you will compare the 33 from your 10, you know these value are not in your sorting fashion, because 33 is greater than from your 10. And as per your swapping concept, sorry, as per your sorting concept, your first value should less than from your next value. So that time 33 is not less than from your 10. So that time your swapping will require. After swapping, your 10 will take the place of your 33, and your 33 will take the place of your 10. Okay. And now your new list will be 14, 27, 10, 33, 35, 19, 42, and your 44. Okay. And we will swap them. And again, you will swap 14 and 10 in your unsorted order. I think all are known about the swapping. So that time, after swapping, your new array will be 10, 14, 27, 33, 35, 19, 42, and your 44. Okay. And this process you will follow until the unsorted value are converted into the sorted sublist. That is the process of your insertion sort. And as per I had told, you will follow this process until your array will sort. After taken the example of your insertion sort, I will discuss about your sorting algorithm. And here I am discussing about the insertion sort. Okay, you know algorithm is your step by step instructions in your sequentially fashion. There is no rule for writing the algorithm. In your algorithm, first you will write this instruction, after that you will write this instruction, after that you will write this instruction. That is no any limit. When we want to write the any algorithm, only you will write the all step sequence by sequence. That is your algorithm. Okay. And now I am discussing about the algorithm of your insertion sort. You can see my shared screen. Yes, can you see my screen? Mariam, Arpret, Pratik, and Tanu Prakash.
No, sir.
I am
No,
asking
sir.
from you, can you see my screen?
No,
No,
sir.
sir.
Okay, 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 okay. Yes. when you will write the algorithm of your insertion sort, in your step first, start is your by default first step of your algorithm. That's why I am not writing the start in your first step. Here in your first step, I am writing if it is the first element is it is already sorted, return 1. If your first element of your array is uh, is already sorted, so means you will return the 1. Okay. And in my second step, pick the next element. As per I had told, if your first element is already sorted, so you will pick the next element. Okay. And after pick the next element, in your step third, as per I had told in the example of your insertion sort, you will compare both elements. Both elements means your first element and your next element. And when you will compare the first element from your next element, if your first element is less than from your second next element, that time your swapping is no required. But if your first element is greater than from your who have picked the next element, that time your swapping is required. And as per I had told in my given example, after swapping, your first element should be less than from your next element. Okay. So in your step third, you will compare with all elements in the sorted sublist. Okay. And in your step fourth, shift all the elements in the sorted sublist that is the greater the value to be sorted. Okay. As per I had told, if your first element is greater than from your next element, so you will swap them, means your next element will take the position of your first element and your first element will take the position of your next element. And in your step fifth, sorry, in your step fifth, you will insert the value. And after insert the value, in your step 6, you will repeat until list is sorted. You will repeat until your list is sorted. Okay. So that is the algorithm of your insertion sort. When you will implement any program, first of all, your algorithm is the first step for writing your program. But some student will directly write the program. That is not a right way. That's why you will always write the algorithm when you want to write the any program. Okay. And after the algorithm, now I am discussing about the implementation of your insertion sort. You can implement this algorithm in any language like your C, C++, Java, PHP, and your Python. There is no any restriction ki you will implement this algorithm only in this language, only in this language. There is no any limitation. You can implement this algorithm in any other language, whatever you want. And now I had implemented this language in your C language. First of all, I have to make the procedure, that is your insertion sort, and where A is your array of items, and I have taken the two integer variable. First is your whole position, and second is your value to insert. There is basically these are the two key points. First of all, your variable will take the which position. As per I had told, if your first value is greater than from your second value, so that time your swapping is required, and your next value will take the place of your first value, and your first value will take the place of your second value. So these are the two key points. First is your whole position, and second is your value to insert. And you will follow a loop which start from your 1 to the length of your array. Okay, and you will insert the value, and your variable whole position equal to the variable I, and locate whole position for the element to be inserted. Means you will locate the position for the element to be inserted, and insert the number at your whole position. And now I am now I will discuss about the advantage of your insertion sort. There are so many advantages of your insertion sort. Main advantage of your insertion sort of its simplicity. Your insertion sort algorithm is very simple compared than the other algorithm like your merge sort, like your quick sort, like your radix sort. So that is the main advantage of your insertion sort. That is your simplicity of this algorithm. This algorithm is very simple because in this algorithm you will apply on the concept of your swapping. If your first element is greater than from your second element, only you will swap them. You will swap them means your second value which is higher from your first value. So your second value will take the place of your first value, and the first value will take the place of your second value. So only swapping is required in this algorithm. That's why the first advantage of this algorithm is that the simplicity of this algorithm. Okay, and second advantage is that it also exhibits a good performance when dealing with a small list. Means if you are dealing with a small list, so that is good. Okay, so your second advantage is that it also exhibits a good performance when dealing with a small list. If you are dealing with a small list means if you are taking the small size of array. And in the third advantage is that insertion sort is in place sorting algorithm, so the space requirement is minimal. You know, if you will take the any variable, obviously your variable will take the place in your memory. Okay, and in this algorithm, insertion sort is in place sorting algorithm, so the space requirement is minimum. So these are the all advantage of your insertion sort. And now there are some disadvantage of this algorithm. So here I have explained some disadvantage of this algorithm. First disadvantage of the insertion sort is that does not perform as well as other vector sorting algorithms. Means this algorithm will not perform as well as the other algorithms like your merge sort, like your radix sort, like your quick sort. So this is the one disadvantage of your insertion sort algorithm. And with n squared step required for even n element to be sorted, the insertion sort does not deal with a hug list. Means if you are taking a large number of size array, this algorithm is not suitable for the hug list. Means for the large list. This list, this algorithm is suitable for the small size of list. So this is the any other disadvantage of insertion sort. And the insertion sort is particularly useful when only sorting a list of few items. As per I had told, this algorithm, this sorting algorithm is best for when you are taking the small size of list, when you are taking the small size of array, not a large size of array. So that is the disadvantage of your array. This algorithm is suitable for a small size of your array. Okay. And now there are some questions which are related from your insertion sort algorithm. First of all, I would like ask from you, is that clear or not? Your insertion sort algorithm. And I am asking from Mariam, Arprit, Pratik, and your Tanu Prakash.
Yes,
Yes, Mariam.
Yes, sir. It's clear.
You can ask any query regarding this algorithm. That is your insertion sort. Mariam, Arprit, Pratik, and your Tanu Prakash. You can ask any query. Okay, clear. Okay. Means Arprit, you have no any problem regarding your insertion sort. And Pratik Mukherjee, okay. Also, you have no any query. Okay, good. If you are having no any query, I am taking some questions which are related from your insertion sort, like your how many passes does an insertion sort algorithm consist of? N minus 1, n plus 1, and your n square. Obviously, you will take the n minus 1 pass when your array of n elements is given, because if you are taking the 5 elements in your array, so obviously that time your size of your array will be 5, and n will represent of your size of your array. Obviously you will perform only 4 steps, that is your 4. Okay. And in your next question, which of the following algorithm implementation is similar to that of an your insertion sort? Binary heap, quicksort, merge sort, and your radix sort. Insertion sort, insertion sort is similar to that of a binary heap algorithm because the use of temporary variable to swap. You know, in your heap, you will use the temp variable to swap, and in your insertion sort, when you will apply the swapping, if your first element is greater than from your second element, that time you will apply the swapping. So in your insertion sort also you will follow the swapping. That's why you can say that insertion sort is similar to that of a binary heap algorithm because of the use of temporary variable to swap. And in my next question, that is your MCQ, what is the average case running time of an insertion sort algorithm? Okay. Average case analysis of your tight bound algorithm is mathematically achieved to be n square. Means average case running time of an insertion sort algorithm is that n square. And next question is that regarding to this lecture, algorithm that sort by exchanging adjacent element require n square on average. Obviously, each swap remove only one inversion. That's why n square swap are required. And next question, next question is that what is the average number of inversions in array of n distinct numbers? Obviously, the total numbers of your pair in a list n minus 1 n minus 1 upon 2, because that's why an average list has half this amount n minus 1 upon 4 inversions. And in my next question, what is the running time of an insertion sort algorithm if input is pre-sorted? So that time I am telling, If the input is your pre-sorted, running time is n because the test in the inner for loop always fails immediately and the algorithm will run quickly. Okay. And next question is that what will be the number of passes to sort the algorithm using insertion sort? Your numbers are 14, 12, 16, 3, 6, 3, and 10. Arpit, I am asking from you, number of passes are required. If you are taking the 6 elements in your array, so that time your number of passes are required. How many number of passes are required? Arpit, Preet. Arpit, I am asking from you, how many number of passes are required? Okay, good. N minus 1. Okay. Arpit, your mic is not working, I think. Okay. N minus 1, N minus 1 passes are required. So in this question, I am taking the 6 element in your array. So how many passes are required? Pratik Mukherjee. Yes, Pratik Mukherjee. How many passes are required? As per. Okay. I am asking question. If I am taking the 6 elements in your array, so how many passes are required in your insertion sort? Arpit is already given answer. Okay, good. Pratik Mukherjee, n minus 1 means total 5 passes are required. Okay. And my next question is that for the following question, how will the array element look like after second pass? Second pass. Your 4 options are given: 8, 21, 32, 34, 51, 64. 8, 32, 34, 51, 64, 21. In your third, 8, 34, 51, 64, 32, and 21. And in your fourth option, 8, 34, 64, 51, 32, and 21. Okay. So after swapping in your second pass, your array will look like 8, 34, 64, 51, 32, and 21. Okay. I hope you have understood about your insertion sort. And now if you are having any query regarding this topic, so you can ask from me. Tanu, Mariam, Arpit, and Pratik Mukherjee. No query. Okay, no query. Okay, good. Means all are understood about the insertion sort.
Yes, sir.